Hey everybody, today we are looking at another lesson from Unit 3. This is Lesson 11, and our target is to explain why a segment parallel to one side of a triangle divides the other sides proportionally. We want to start with parallel segments and proving a little bit of proofs here. We're given that line AC is parallel to line MN. And how would we write an argument or share with a friend that would be convincing, that would convince a skeptic that, hey, triangle ABC is similar to triangle MBN? And the first things we want to do, I'm going to give you a couple minutes, ask you to pause at this point and to kind of think through what you think we might want to do. Again, the lines are parallel. What do we remember about parallel lines? Okay, now that you're back and we've had a few minutes to think through this, hopefully you're saying, well, Leipold, I know when there's parallel lines, we have congruent triangle or congruent angles. And so in this case, our angle here at A, this angle, should be congruent to several other angles, but most specifically ones that are of interest to us today is this angle here, this BMN. Is congruent to BAC, so because the two lines are parallel. Also, we have, and that's because of this transversal line segment AB, we can call that a transversal. We have the other transversal line segment CB, and it would be also forming some congruent angles here. We have the angle here at C. Okay, and it's going to be going to be congruent to the line BNM, and that's because of the parallel situation between lines AC and MN. And we just learned the last time we were all together that all we need is two angles that are congruent, two angles in one triangle that are congruent to two angles in another triangle, and voila, we have similar triangles. So that should be enough for that skeptic. Okay, moving on. So now that we know that these two triangles are going to be similar, what are some ratios that we remember from last week that would have to be also congruent? So at this time, if you would, again, pause. And I'd like you to take a couple minutes and then complete these blanks. Okay, welcome back. Well, I filled in a few already. And what we hopefully are agreeing on is that AM over MB is equal to CN over NB, and CB over CN. That would be equivalent to the ratio AB over AM. And then one that you might, one I just wanted to throw in, I wanted to take a look at that segment AC and MN. I see that those two triangles would be similar. So can we say that AB over MB is equivalent to AC over MN? Talk with your teachers about it. Okay, now the preponderance of proportional relationships. Ooh, say that 3 times really fast. Segments BD and FG are parallel. Segment EG is 12 units long, and segment EB is 2.5 units long. So we want to go through and find the lengths of each unlabeled side. Again, I'm going to ask you to pause the video, write in your answers, and then jump back on and see if you got the same answers I did. Okay? Okay, so if you're back, I thought 7.5 and 4 would work because I noticed that a couple of things, and I didn't write them on here. Let me do that for you real quick. So we have EG. This EG we noticed was 12 units long. They said this was 12, and they said that E to B is 2.5. 2.5. So we know that the ratio going from the smaller triangle, BED to FEG, that was 3 times. We take 5 times 3 to get 15. So we're going to take 2.5 times 3 to get the length of E to F. And so if you do that multiplication, it would be 7.5. And we know that E to D is 1/3 the size of the segment EG. So taking 12 divided by 3, remembering that reciprocal situation there, then we have that this segment should be 4. Now we're going to check our work. And yes, we're correct. Okay, finally, I just want to pull all this together for us. So just like whenever were learning about parallel lines and understanding when they're cut by a transversal, parallel lines have a special situation where there are lots of angles that have the same measure. Here we're saying that when we have triangles and or have a triangle and we make a parallel line, a line that's parallel to one of those sides, then we're going to be forming a similar triangle. Now we're saying that if those two segments happen to be parallel, then we have a situation again where the two triangles that are formed are again similar. Hopefully that makes sense to you guys. Anyway, you can read it through here, and at the end of this, I have just a little confidence check for you. We're at section 11 now with unit 3, and I'm wondering, how confident are you understanding similar triangles? Are you feeling pretty good about the things we've been doing in this last unit, or there are some things that you're still needing help with? Either way, let us know. If you need to say a little more, you need to touch base with your teacher, please do that right away so we can get you the help you need before we take that final test when we get back from the break. Have a great day.